The introduction of Zhongyi.
Hi, I'm Silver from Wuxi Zhongyi Smart Technology Limited Company. Today I'm going to introduce and display our products for you. If you find it useful, please give me a thumb up and follow us. If you have any questions or inquiries, welcome to send me a private message, and I will give you a professional reply.
The overall appearance of the single-flow non-valve controlled water meter.
Today I'm going to introduce our smart water meters to you. This is the on-valve controlled smart water meter. Here's the LCD screen. The base is made of all brass materials. And this is the filter screen.
The inner structure of the single-flow non-valve controlled water meter. The main parts of the single-flow non-valve controlled smart water meter are as follows. Here's a brass shell basic meter. There's an in-flare, waterproof plate, pressure plate, magnetic rod, hall sensor, bracket button, metering plus control plus communication circuit board, and battery plus supercapacitor in the inner cavity. Besides, there are clamp, sealing ring, and transparent shell. Now I'm going to show you how to install the single-flow non-valve controlled smart water meter. This is a brass shell-based meter. Please pay attention to the diamagnetic ring in the middle. Then install the hall sensor, the battery, and the metering communication board. Next, put on the sealing ring and apply a little bit of glue. Then install the case and snap onto the basic meter. At last, put on the clamp. Finished. The overall appearance of the single-flow valve-controlled water meter.
Here's the valve-controlled smart water meter. The meter plates are made of two parts. The first one is the mechanical metering plate, and the next one is LCD screen. The base is made of all brass materials. Here's the valve. At last, this is the filter screen.
The inner structure of the single-flow valve-controlled water meter. The main parts of the single-flow valve-controlled smart water meter are as follows. The base. The all-brass pipe section base meter. The outer casing. The communication metering board. The battery. The actuator and other spare parts. Now I'm going to show you how to install the single-flow valve-controlled smart water meter. Install the dust plug. Pass the metering data cable of the base meter through the base. Fix the base meter and the base. Install the actuator and put on the cover. Install the metering communication board. Install the battery. Put on the outer shell. Finished. The metrology principle of the single flow water meter. Now let me explain the working principle of the single flow electronic water meter. The main parts are the Hall effect sensor, the turbine, impeller, and the magnet. Water flows in from the inlet and flows out from the outlet. The water flow drives the impeller to rotate, and the magnet on the impeller rotates too. The magnetic field rotation triggers the Hall sensor. It outputs pulses. The amount of water flowing through each revolution is fixed, and the number of pulses outputs are also fixed. Therefore, we can calculate the amount of the water flowing by calculating the number of the pulses. The screen display of the single flow or multi-flow non-valve controlled meters. The LCD screen of the water meter is always on. Approaching the screen with a magnet can trigger screen rotation. Here the screen display, except lower one. The lower right corner displays the total flow. The top left corner displays the current balance. Here are the icons of the state of the valve. The tick mark means opening the valve, and the cross mark means closing the valve. By default, the non-valve controlled water meter displays the valve opened icon. The top right corner displays the battery capacity. P1 to P3 displays the communication number IMEI of the water meter. It's displayed in multiple screens due to the length. This is the test verification mode, which displays the current flow, the numbers of the pulses, and the flow rate. This screen displays the factory test mode. This screen displays the version number. The LCD screen of the water meter is always on. Approaching the screen with a magnet can trigger screen rotation. Here the screen display of lower one. The lower right corner displays the total flow. The top left corner displays the current balance. Here are the icons of the state of the valve. The top right corner displays the battery capacity. P1 to P3 displays the communication number DEVEUI of the water meter. It's displayed in multiple screens due to the length. D1 to D2 displays the network access parameters of the water meter. This screen displays the current mode of lower one, which is Class A, Class B, or Class C. This screen displays the version number, the installation of the nuts of the single-flow non-valve controlled water meter. Now I'm going to show you how to install the water meter. First, insert the nut and install the washer. Then, wrap it with 2 rings of Teflon tape and tighten clockwise. The other side too. Attention! The direction of the mouse water flow arrow is the same as the water flow direction of the water pipe. The battery replacement of the smart water meter. Generally, the battery of a smart water meter lasts for 6 years. If we need to replace the battery, open the cover and dashboard. Then unplug the terminal and the battery again. Pay attention to the positive and negative of the terminal wiring. The red wire is positive, and the black wire is negative. The communication methods and the principle of smart water meter. There are many remote communication methods for smart meters. The common ones are LoRaWAN, NB-IoT, GPRS, Wi-Fi, RS485, and M-bus communication. The LoRaWAN water meter connects to the LoRaWAN gateway by sending wireless radio frequency signals, and the gateway transmits data to the system via 4G wireless. LoRaWAN has 3 working modes: Class A, Class B, and Class C. If the water meter only reports once in several days, and the delay requirement is not high, the Class A mode can be selected. If the water meter requires real-time communication, we can select the Class B mode. The GPRS, NB-IoT, 4G water meter communicates with the server through the operator's communication base station. They belong to UDP short connections and will automatically disconnect to save power after successful communication. The Wi-Fi water meter doesn't need a collector or concentrator. By connecting to a Wi-Fi router, the router transmits data to the system through 4G wireless. The data of RS485 water meter is transmitted to the IoT concentrator through the RS485 bus, and the concentrator transmits the data to the system through 4G wireless. The data of M-bus water meter is transmitted to the IoT concentrator through the M-bus bus, and the concentrator transmits the data to the system through 4G wireless. Now let's compare the characteristics of different communication methods. The LoRaWAN, GPRS, NB-IoT, 4G, Wi-Fi meters are all wireless meters with built-in communication modules. The RS485 and M-bus meters are wired meters. The low-power meter is powered by a lithium battery and doesn't require an external power supply. The introduction of the communication modules. This is the metering communication board of our non-valve-controlled, valve-controlled smart water meter. The common system operation of the water meter. Log in the system. Log into the integrated energy metering and control system. Then enter the account and password given by the factory. Click the water meter system. File management. Click System Management, File Management. Select customer's name and display the water meter list. We can see the current operating status and on-off valve status of the meter. Click Import Meter File. Select Upload Excel file, and the import is successful. Edit the meter information. Select a meter and click Edit to view the information of the current meter, including the customer's information, corresponding collector, concentrator, price plan, prepaid or postpaid, overdraft amount, and alarm amount. Also, we can view the meter's address, model, and the communication code of the device. The gray area can't be modified. Other information can be edited and received. The test of the single flow water meter on the testing bench. This is our smart water meter testing instrument. Here's the testing bench. As you see, there are several meters in test. This is the common control system. You can see the data of flow measurement. Now I'm going to show you how it works. Let's test the large flow first. Click the Q3 button. Then the medium flow. Click the Q2 button. As last, click the Q minimum button to test the minimum flow. Use a magnet to switch the screen to the test verification page, which displays the current flow, pulse number, and flow rate. They switch cyclically. The communication test of the serial tool of the water meter. This is a serial tool, USB to TTL. There's a USB port on one side, which connects directly to the computer. This side is a TTL pin, which connects to the meter end. Pay attention to the three pins TXD, RXD, GND on the serial tool, which corresponds to TX, RX, D on the communication board of the meter. Connect both ends. AT command test. Open the serial port test software. Then enter command AT. Select the serial port and select the baud rate. Here are the serial port parameters: port number, baud rate, data bits, stop bits, transactions, water flow control. Click Send command. The meter will return OK after receiving the command. Query APN. Input command. AT plus APN ? Click Send to query the current APN of the device. Reset APN. Enter the command AT plus APN equals IP, new APN name. Click Send, and you can modify it to a new APN. Read current IP. Enter the command AT plus remote ? Click Send to query the current IP address. Modify IP address. Input the command AT plus remote equals IP address, port number. Click Send to modify it to a new IP address. Each meter has a function description list, in which the AT command section has a detailed description of all commands. The burn program of the water meter. This is an offline programmer. One end of it is a USB port to connect to the computer, and the other end is a programmer port to connect to the communication board. Pay attention to the pin identification. The ports on the programmer are marked with VEXT, GND, DIO, and CLK, corresponding to V, G, DIO, and CLK on the board. Connect the programmer to the computer. A U-disk icon will appear on the computer. Open the U-disk and copy the program files to be burned into it. Click the scroll button to select the program file to be burned. Click the program button to start burning. White flash, click OK to start burning. The progress bar is full, and the burning is complete. The communication test of the water meter. The communication test of the water meter with LoRaWAN. Query and issue the data test. Select device type. Then select issue data test and query the total flow. Click send. Trigger with a magnet. When we see send true, it means the report was successful. Note that only Class A needs to be triggered with a magnet. Class B and Class C do not. We can see information in the system. Click down and the report details will appear, such as total flow, voltage, signal value, signal to noise ratio, and class mode eccentric. Set the total flow. Look at the total flow of the meter first. For example, it's 1.4 now. Select command. Set the total flow and set the value to 1.4. Trigger it with a magnet. If send true appears, it means the command was sent successfully. Valve closing test. Select command. Valve closing. Click send. If send true appears, it means the command was sent successfully, and we can see the meter to start closing the valve. The cross mark, valve closing icon, is displayed on the screen. Valve opening test. Select command. Valve opening. Click send. After sending successfully, the meter starts to open the valve. The tick mark, valve opening icon, is displayed on the screen. The communication test of the water meter with NB-IoT. Select command. Total flow query. Click send. Trigger with the magnet. When the link true appears, it means the connection to the base station is successful. Receive true means the acceptance is successful. Send true means the command is successfully issued. You can see the information in the system. Click down and the report details will appear. Set the total flow. Look at the total flow of the meter first. For example, it's 0.365 now. Select command. Set the total flow and set the value to 0. Trigger it with a magnet. If link true, receive true, and send true appear, it means the command was sent successfully.